Hello and good evening everyone. Welcome to Matholics. This is the session for how to solve numericals for class 10 physics. This session is self-curated only for those students who are weak in numericals. Okay. You know the theoretical part, you know the definitions, you are memorizing everything, but numerical part, you're not able to solve. Okay. So we'll be solving numericals for this class 10 physics. Class 10 physics will be solving all numericals. Electricity, concave convex mirrors, concave convex lenses, है ना? Like that. Okay, so we'll be starting the session in next 1 minute. Game changer batch, always super. Thank you so much, Akash. Thank you so much, bache. Chali. So we'll be starting the session. This game changer batch is for those students who are actually not able to afford anything. Okay. In this batch, I will not be talking one-to-one, but in this batch, if anyone wants to improve, he can. If the will is strong, you know the phrase, the where there's a will, there is a way. So everyone can find the way if he or she wills. The price is so low, just rupees 999 for a batch for 3 months. Can you expect just rupees 999? This will be similar to YouTube lectures, but I will not be talking to anyone. I'll just be coming, teaching and going. We'll be getting questions, that's it. But you can improve if anyone is interested. Okay, so we'll be starting the session in next 1 minute. This is the session for how to solve numericals for class 10 physics. So let's count 3, 2 and 1 without wasting time. See, first we'll be starting with convex and concave mirrors, right? So what is the basic scenario between convex concave mirrors? You must know how to draw ray diagrams. You must know how to draw image formation diagrams for this particular topic. You must know this. Solving PYQs and everything is else. Okay, but we'll be solving questions from this book, Lakshmi Singh Manjeet Kaur. Okay, numericals from this book. Amazing book. PYQs also will be solving. Everything will come on time, don't worry. Okay, in the series of lectures for this one coming week or 10 days, we'll be solving different types of good questions, only numericals, right? So for concave mirrors, now see how to draw a concave mirror. Concave mirror, see, let me tell you the basic difference between concave and convex. Concave, there is two C's coming. In convex mirror, in convex, there is only one C. So the diagram will be like this. Okay. This is the main difference. We have also drawn here. So let's remove it. Let's remove it. See, this is the main difference between concave and convex mirrors. Okay. Focus onto this highlighted diagram. This is concave mirror. This is convex mirror. Why convex mirror is like this? Because there is a single C, just to memorize. Single C, C means convex. Single C. Convex spelling also there is single C. But in concave there are two C's, so it will be opposite of that C. So ulta fulta C. So this is like this. Always the opaque part is on the right side. See, this dash part is on the right side. Here also it is on the right side. Now why it is important to learn ray diagrams before? Now, why to remember ray diagrams just before solving numericals is the same as you must know the ABCD before making a sentence or making a letter or making a word. Yes or no? This is the simplest way to learn how to solve numericals. Okay. Now see. This is a concave mirror. A ray of light coming parallel to the principal axis will get reflected back along the focus. See, if you can see this, the ray of light is coming like this and it is going in this direction. Yes or no? So this is for concave mirror, that if a ray of light is coming parallel to the principal axis, it will go through the focus. It will reflect it back along the focus, right? Wait. Sorted. Sorted. Now, next case number 2. Rule number 2. If a ray of light is coming from focus, it will be reflected back in a direction which is parallel to the principal axis. This is the principal axis. See, this is the principal axis. Okay. So, if a ray of light is coming through focus, it will go parallel, right? So, these are the different types of cases which you must know. Third case, if a ray of light is coming from the center of curvature, this is C. How to draw? This is the diagram. This is the principal axis. This is pole. This is focus. This is center of curvature, right? Pole, focus, center of curvature. Next case is a ray of light which is incident on the mirror coming from the center of curvature. It will be reflected back along the same path, right? Last but not the least, the ray of light which is incident of the pole, incident on the pole. Say this is the concave mirror. This is the principal axis. A ray of light is coming like this. If this is angle incidence, so the angle of reflection will be same. This angle will be equal to this angle. These angles will be same, right? So coming this direction to the pole, it will be reflected back like this. Okay, so you can draw these four sets first, or let us complete the sets. Okay, so these are four rules. Image diagrams are six, sorry. So four rules for obtaining images in a concave mirror. Draw this and we'll be moving forward. 5 minutes, okay? Copy fast. Can you please repeat the third one? Third one. Third one. It is going through the center of curvature and coming, reflecting back along the same path. Hello. Oh my God. I'm so selfish. I didn't knew that. Which chapter? Chapter is, these are mixed chapter questions, but this chapter is light from the chapter physics. from the topic physics. Class 10 physics, the topic is light and subtopic is rules for obtaining images by concave mirror. Start from starting, not possible. Okay, can we move forward? Sorted? Okay, I guess it is done now. Okay. Uh, it is done now. Okay. The 4 rules for obtaining images formed by a concave mirror. Now comes image formation of images by a concave mirror. Now comes on the topic image formation by a concave mirror. Formation of images by a concave mirror, right? So in a concave mirror, see, there are 6 positions possible. If this is the concave mirror, this is the pole, this is focus, the center of curvature. The distance, this must be equal to this. There are 6 conditions, right? 6 conditions. One is between pole and focus. Second one is at the focus. Third one is between center of curvature and focus. This one. Fourth one is at the center of curvature C. This is called as beyond C, just back of C, beyond C. And this is at infinity. So there are 6 positions at which object can be placed in a concave mirror. Clear? There are 6 positions. 6 different positions at which the object can be placed. Now case number 1. When the object is between P and F, we'll draw these diagrams again, don't worry. We'll draw these diagrams again. Case number 1 I'll be drawing. Case number 1 I'll be drawing again. Case 1. Case 1. When the object is between P and F. Object between P and F. See, if this is the concave mirror, this is the pole, this is focus, right? And this is center of curvature, right? The object is there. This is the object between P and F. Okay, can you see this object clearly? Object is between P and F. So a ray of light will go like this. Okay. We know if the parallel ray is going, it will come from the focus. Yes or no? Yes, sir. And if the ray of light is going towards the pole, second ray of light I am drawing with red color. See, this is coming towards the pole, so it will be reflected back along this. This angle will be same. Yes or no? Yes, sir. So can you see these rays are expanding? Image is formed always when 2 reflected rays intersect. Whenever an image is formed, tell me, image is only formed when 2 reflected rays. Sir, screen, you can, everything is good now, okay? Image is always formed when 2 reflected rays intersect. So we'll see these can intersect only when produced backwards. See, this also will be produced backwards. So we'll say this is the image formed. This is the image formed. Again, you see this thing very clearly that this image is formed, it is behind the mirror. It is, image formed is behind the mirror. Yes or no? Behind the mirror. Second point, what kind of image it is? It is virtual and erect. Erect means upright. Like this. This is erect. and if it is downwards, it is inverted. Okay. Virtual and erect. And third point, is it larger or smaller than the object? Object is this much, image is this much. So this is magnified. Magnified or larger than the object. Copy this first case. Copy this first case. We'll be solving every case. Copy this case number 1, then we'll be doing case number 2 and so on. So yes, when two reflected ray intersect. So I'm new and I'll start my study. Like, can you give me strategy, complete physics, solve numericals, wake up early in the morning, and so you do. Yes, we do live regularly. Done. Case number 1. Come on, everyone. Have you copied this? We have to move on. Come on, this case. Why waiting so much? Okay, case number 2. This was case number 1. Case 2. Now, when object will come onto the focus, when object is at focus F. Object is at focus F. Now, when the object will move towards focus F, what will happen? Again, we have to draw this diagram. Okay, sir, draw this one. Fine. This is pole, this is focus, and this is center of curvature. Object is at the focus, right? So ray of light will go parallel. It will pass through the focus, or it will go to the pole, and it will go. Oh my God! Right, and it will go like this. So can you see these rays are parallel? Can you see these rays are parallel? So where will the image be formed? They will intersect at the parallel rays will intersect at infinity. At infinity. So we'll say image formed is, for the image we can say image formed is what? Image formed is First point, at infinity. Sorted. Infinity means very far away point. Point number two, it will be virtual or it will be real. Tell me, it will be real because they will intersect at infinity, and inverted on the downside of this axis. So we'll say real and inverted. Real and inverted. At least 4 to 5 marks numerical will come. Concave mirror, convex mirror, or concave lens, concave lens and convex lens. Third, it is large or very large. It is very large. So we'll say highly magnified. Highly magnified than the object. Copy it. Case number 2. Very easy. Very easy. Copy. Done. Can we move forward? Okay. Case number 3. This is case 2. Let's go to case number 3. Case 3. Where will the object be placed? Anyone? Between F and C here. Object is between C and F. Center of curvature and focus. So this is the concave mirror. Okay. This is pole. This is focus. And this is center of curvature C. Okay. This is center of curvature C. So whenever we'll place the object, we have to place here. Okay. Between F and C. Now see, the ray of light will go like this, parallel. It will come from the focus. Okay, sir. One is going towards the pole. Okay. Let's make some another line that one is going from center of curvature. See. Center of curvature, it will go like this. This is the mirror. It will get reflected back along the same path. Intersection point will be the image, yes or no? Okay. Or you can draw through pole also. Image will be formed at this point only. Let's see. Delete it. We are going to delete this. Wait. See the magic of physics. Okay. This is the magic. We have marked this point. There only the image will be formed. See. That will go towards the pole. Okay. Strike towards the pole. Strike the image ray towards the pole. It will reflect it back along the same path. Let's draw neatly. Oh my God. Where it is? Here it is. Okay. See. I'll draw single ray going towards the pole from here to here. From here to this is the pole. See. Oh my God. See. This is the point where image will be formed. Because these two rays are coming and intersecting over to this point. Right. These two reflected rays are intersecting at this point. So this will be the point of intersection. So we'll say image. This is image. This is the image I drawn. So image formed is what? Tell me. Image formed is point number 1. Where it is being formed? Beyond C. Just behind of C. So I'll write it as beyond C. beyond C, center of curvature. Point number 2, it is real or inverted and virtual and erect. Tell me. Yes, sir. Yes or no? This image is what? Real and inverted because it is in front of the mirror. See, this is the, if you have to draw like this. This is the concave mirror. This is the concave mirror. Always draw the opaque part. Draw. I forgot to draw. Every one of you must draw this. The opaque part on the right side. Oh my God. This opaque part must be on the right side. Draw this. I forgot. Sorry. Right. So these are the small things of which you can let your marks deducted from your teachers in your exams. Okay. So this is the point. Second point, first is beyond C. Second point, it is real and inverted. Real and inverted. Okay, sir. Last but not the least, the image is what? Larger or smaller than the object? Tell me. This is this. Is it larger? This is small. This is larger. So image is magnified. Not highly magnified. Highly magnified was on the case when object was at focus. When object at focus, image will be highly magnified. You never know where it is going to be formed. Okay. That is the bigger image. From this axis we count, this length will be very large. But from there we can measure this. So if we can measure, it is magnified. Okay. Copy it. Copy it, copy it, copy it. If you do the ray diagrams fast, we'll be solving numericals also today only. Done, done. Okay. Now see. This is case number 3. Now case number 4, object will come onto the center of curvature. Object will come onto the center of curvature. Case number 4. Case 4. Object on object at C, center of curvature. So again we'll make this convex. See, diagram must be super perfect. If the diagram is not perfect, you are not going to get marks. This is pole, this is focus, this is center of curvature. Now where the object is placed? Object is placed beyond C means, say here the object is placed. Okay. So how to make diagrams? Okay. You can see the lecture again and again. I cannot repeat. Sorry. Okay. I cannot repeat. For anyone, I cannot repeat. This is the object. Now the ray of light will go parallel. Okay, parallel, parallel, parallel. It will come from the focus after reflection. Yes or no? It will come from the focus after reflection. Yes or no? What's happening here? Okay, sorted. Can you see the diagram properly? Yes or no in the comments? Yes, sir. Okay, so this is the reflected ray. This is the reflected ray. Now see another ray. From where you can draw? You can draw through the focus. It will go parallel. Okay, let's draw through the focus. Okay, from the pole, it will come like this. Image will be formed here. If from the focus, it will go parallel, image will be formed here. See the magic of physics, Any rule you follow, the diagram will be same. So we'll make the diagram again mentioning this case. This is a beautiful case. Okay, see, I'm going to delete these images. Okay, we'll make again, right? The ray of light will go to the pole, it will come same angle, or it will go through the focus. It will go through the focus and it will be reflected back in a direction which is parallel to the axis. It will be reflected back along a direction. What's happening? I don't know. It will be reflected back along a direction which is parallel to the axis. Okay. So where two reflected rays are meeting, this is reflected ray. Also you can see this is the reflected ray. So they are meeting towards this point. Okay. So this point will be the image. This point is the image. This is image, right? Here you can see this is image. You can write down in the previous diagrams also image, where the image is being formed. So this is the image. So image formed is what? Anyone tell me? Image formed is what? So what nature? Tell me, first point. It is, where is it formed? Between C and F. It is between C and F. Point number 2. Is it real and inverted or virtual? It is in front of the mirror. So it is real. And downward direction means inverted. Real and inverted. Point number 3. Smaller or larger than the object? This is object. This is image. Tell me, the image is smaller or larger than the object? Tell me fast. The image is, what kind of image it is? Smaller or larger than the object? Fast. Larger than the object. Yes, it is smaller than the object. Larger, yes. Larger than the object. That means magnified. Oh, smaller or larger? Tell me. Larger? How's it larger? Object is this, image is this. It is smaller. Smaller than object. Smaller than object. So we can write it as diminished. We can write it as diminished. Diminished means smaller than the object. Okay. Copy this. Sorted. Copy, copy, copy. Copy this. So this is case number 4. 2 remaining cases we'll be doing. Copy this. Yes, it is smaller. It is not larger. Smaller image means diminished. Smaller. Case number 5, you do yourself. Case number 5, you do yourself. Case number 5. It will be when object is at C, center of curvature. Do it yourself. Anyone drawn the fifth case? Tried the fifth case? Can tell me in the comments. Yes, sir. I was here only, but some important work was there. Come on. Diagram not making, not making, not making. Okay, let's draw. Let's draw the diagram for case number 5. See, diagram for case number 5 will be what? See, draw again, same sir, concave mirror, sorry. This is the pole, this will be the focus, this will be the center of curvature, right? Now see, this distance same, okay, same. Now object is at, when object is, not at C, beyond C already done. Object is at infinity. Object is at infinity or C. Okay, let's move, make it at C. Wait. Case 2, case 3, C and F at C. This was beyond C. Make it a correction. Object beyond C. Object beyond C. Beyond C would mean object is behind C, behind center of curvature. Now we'll make object at center of curvature. Object at center of curvature. Okay, this is a smaller mistake. Please correct it. That this is object beyond C case. That object is not at C, it is beyond C. And when object is at C would mean at center of curvature. Okay. Sorted. Object is at center of curvature. Okay. So we'll place the object here. Okay, sir. This is C. Now place the object here. Diagram must be very clear. Object is at center of curvature. Okay. You draw a line parallel. You draw a line which is parallel to the axis and will come through the focus. Say yes or no, sir. Yes, sir. Another line which will going through the focus, which is going through the focus or pole, like this and like this. Okay, first we draw, this one is easier. Okay, it will come like this. So can you see, if you draw it properly, can you see this is the image, this is the image, right? This is the image. Above it there was, this is the object. Okay, so image and object size, what, who can tell me in the comments? Image and object size, is it equal, is it larger or smaller or what? Tell me. Tell me in the comments fast. Tell me in the comments fast. Image formed is same. Yes. Image formed is, first point, where it is? At C, at center of curvature. Second point, what kind of image it is? Real and inverted. Obviously, sir, real and inverted. Third point, is it large, is it small or same size? It is of the same size as of object. Copy this case number 5. Copy this. Copy. Copy. Object is at center of curvature. When object is at center of curvature, the image form will be of same size. Done, done, done. Case number 6. Case number 6. When object is at infinity. When object is at infinity. When object is at infinity. This is pole, this is focus, and this is center of curvature. Try to copy fast. Why wait every time? When object is at infinity, see, this ray will come like this. In this way, you are not going to complete the paper in exams also. If this is parallel, obviously the object is at infinity, the rays will be parallel. It will go through the focus. Another ray which is coming parallel will also pass through the focus. So we'll say image is formed at the focus. Simple case. Image formed is first point at focus. Second point, it will be real and inverted. Third point, it will be highly diminished. See, how large is the object? Highly diminished. Highly diminished means very smaller than the object. See, the object is of large size. Image is forming as this point image. So point image will be always highly diminished, very, very small. Okay. Copy this fourth one. No, last one, sixth one. This is the sixth case. You can see this case like this also. Wait, let me show you another example of this case. Another possibility of this case. Case number 1, 2, 3, 4. See, one image is one ray is coming like this, so it will go lower than the focus. One image, ray is coming towards the pole, it will get reflected with same angle, angle I equals to angle R. So this will be formed of real and inverted, very, very small, right? You meanwhile copy that case only. Case number 6. Okay, this one is the case. Copy this one. This one is the last case for now. Copy, copy, copy. I'm waiting for 1 minute. Done? Okay. Next, coming on to questions. Okay. But before questions. Okay. This is a simple table. You can take the screenshot and copy it afterwards. That where is the object between P and F? What will be the image formed? Where will be formed? What is the nature of image? Like that. This table is homework. You can take screenshot and make this table in your notes copy. Okay. Now, no, no. We'll be doing questions. We want to the mirror formula. Okay. Write down mirror formula. What is mirror formula? First formula for you all. Sign convention for mirrors. Okay. First is sign convention of mirrors. What is sign convention? Which direction to take positive? Which direction to take negative? Heading mirror formula. In that, it will be sign convention of spherical mirrors. Now, this is concave mirror. This is convex mirror. The upper values will be treated as positive. The lower values will be treated as negative. Upper ones always positive. Lower ones always negative. Values which are right of the axis towards the right side will always be positive. Which are on the left side will always be negative. Right? Just memorize these things. If you if you copy, it will take too much time. Okay. You just either take screenshots or copy it afterwards. Okay. So this is concave mirror, this is convex mirror. This is direction of light. Okay. Upper value is positive, lower value is negative. Left value is negative, right value is positive. That's it. For concave mirror, focal length is on the left side. Focus is on the left side. So focal length will be negative. For convex mirror, focus is on the right side. Focus is on the right side. So focal length will be positive. One thing. Tell me object height. Height of object. Object is always upper than the axis, upside of the axis, upper side of the axis. So upper side values are always positive. So object height is always positive. Object height is always positive, right? Image height we'll see according to the questions, right? But object height is always positive. Focal length for concave mirror is negative. Convex mirror focal length is positive, right? This is the whole complete which I have talked right now. This is written over here, okay? This is written over here. Next, mirror formula. Main formula for today's evening, it is mirror formula. 1 by f equals to 1 by v plus 1 by u, where f equals to focal length, v equals to image distance. Distance of image from the pole, right? What is u? U is object distance. These both are measured, all are measured from the pole. From the pole. From the pole, right? From the pole. All these three things are always measured from the pole. Clear? Sorted? Copy this mirror formula. 1 by f equals to 1 by v plus 1 by u. These are different. See, now this formula is to be used in numericals, obviously. How to use? We'll tell you. Don't worry. Tough questions, I think that will be covered tomorrow, but today is the base of those tough questions. Okay, so be prepared for tomorrow also. Now, one more thing is linear magnification or just magnification. Magnification equals to h2 upon h1, where h2 is what? Height of image. h1 is what? Height of object, right? First formula was this. Second formula is this. M equals to h2 upon h1. Height of image upon height of object, right? Clear? So that's it for today. Copy these two formulas. We'll be having questions tomorrow. Till then, goodbye. Take care. But these formulas you must memorize. All the 6 cases you must memorize. All the 4 ray diagrams you must memorize. We have drawn 10 diagrams today. 10 diagrams. Listen my words. 10 diagrams. At least repeat once. And 2 formulas. These 12 things you must repeat once. We'll be meeting tomorrow. Goodbye. Good night.